How does ROS work in robotics explained? Imagine a robot that can talk to its parts, understand what it sees, and decide what to do next. That's where Robot Operating System, or ROS, comes into play. It's not a traditional operating system like Windows or Mac. Instead, it's a flexible framework that helps different parts of a robot work together smoothly. Think of it as a communication hub that connects sensors, motors, cameras, and AI algorithms. ROS organizes robot software into small units called nodes. Each node is like a mini program that handles a specific task. For example, one node might control the robot's arm, while another processes data from a camera. These nodes don't need to know about each other directly. They talk by sending messages over channels called topics. If a node wants to share information, it publishes a message. If another node needs that info, it subscribes to the topic and receives the message. The ROS Master acts like a traffic controller. It keeps track of all active nodes, topics, and services. When a node starts, it registers with the master. This way, nodes can find each other easily. The parameter server stores settings that nodes can access during operation. For instance, it might hold data about motor speeds or sensor thresholds, which can be changed on the fly. ROS supports programming in languages like C++ and Python. This makes it easier for developers to build complex systems by combining many small, focused nodes instead of one big program. In advanced robotics and artificial intelligence, ROS works seamlessly with deep learning tools. For example, a deep learning model running inside a ROS node can analyze images from a camera to recognize objects. Then, it can send commands to the robot's navigation system to avoid obstacles or interact with the environment. You'll find ROS used in self-driving cars, robotic arms, drones, and service robots. Its open-source nature allows quick testing in virtual environments before deploying on real robots. Developers can simulate robot behavior, test algorithms, and then move to physical hardware without rewriting code. In essence, ROS provides a clear structure for robots to communicate and work together. It manages the flow of information between sensors, actuators, and AI systems. This setup makes it easier to develop intelligent robots that can learn, adapt, and perform complex tasks. That's why ROS is the go-to platform for building smarter, more capable robots today.